So welcome everybody. I'm happy to present the solution we developed at DocuTeam in Switzerland. I'd say for the last, now it's actually for the last 3 years probably, because I mean, most of the work was done last year. And then, as you already see, the subtitle is how we fixed it. What we delivered to the clients and thought we were ready last year had some problems, and I'm gonna go into that. We already talked a bit about it yesterday. Yeah, but also what we did to like resolve these problems or at least improve the situation. I mean, some might even be related to using OCFL and so on. But yeah, we'll see later in more detail. Before I go into more also technical details, I want to give a brief overview of our stack. And I mean, that's not the whole stack. That's like we call it repository stack, which is basically, I don't know, do you see my my mouse here if I point to something?
Yep, we've got your mouse.
All right, good to know. Yeah, so we have DocuTeam Box. That's, as the name already suggests, is our own implementation or application, which acts as kind of an API layer above all the tools we have down here. Not that we don't trust them, but to make it easier for external applications and users or the systems to have like one single point where they interact, and they don't have to know, is the data coming, is this now stored in Triple Store or in Fedora directly, and where do I get the binary, or should I access the file system, and so on. So that abstracts that away. And I mean, we also have the need to give some backwards compatible APIs that are actually, I mean, a re-implementation of all the APIs we had in the Fedora 3 stack, and to keep tools around it working for now. And we're planning to do like a version 2 of the APIs that has more features and so on. But there are also some new APIs. And then we have basically 4 components, I'd say. I mean, obviously we have Fedora. That's like our main storage. That's where we write everything. Like, we store all the data in Fedora, of course. And then Fedora sends out messages. Most of you might know that's done through ActiveMQ. And we are using the Camel toolbox that then handles these messages and does the indexing in Fuseki Triple Store. Our setup normally is that this all runs on one single server, but in a Dockerized environment. So it's basically a Docker Compose or Docker Stack that runs on a single machine. So we don't have much network latency within this stack, but of course we have some limitations on how much resources do we give each client, especially in the cloud. And I think we're still figuring out a bit, should we do larger instances, but maybe add even several clients into the same instance, or should we have very small ones and more separated from each other? Yeah, and as I wrote down here, the errors are kind of not who calls who, but more, well, DocuTeam Box or an external application writes into Fedora. Fedora then sends out messages. Camel Toolbox actually gets those messages and then writes data into Fuseki. what's missing here. Of course, Camel Toolbox will also get data from Fedora, but I think concept is clear. And then Box doesn't do any updates to Fuseki because updates are done over here. But depending on what kind of data we need, or if we need to like construct some different part of the data, we do that through Sparkle basically. And I mean, that's not that different from what we had with Fedora 3. We didn't have like an external triple store. We had Gsearch, which does the indexing into, in our case, a Lucene index. I think you could also do a Solar index or something. And there wasn't, the Camel Toolbox part was actually integrated into Gsearch for those of you who still know Fedora 3 and the stack that's involved with it. Like the main part of this whole restructuring and what we wanted also to do with the update or upgrade to Fedora 6 is not only just migrating all the data, but also switching to a different data model. In Fedora 3, we used an XML-based data model storing basically EAD and premise data streams, and of course the binary files in Fedora 3. So we had like more technical metadata and descriptive metadata for our archival records. And we are now have a custom migration path that doesn't use the migration utilities because we want to do this whole data model transformation as well. And our new data model is focused around the records in context ontology, which I mean is still in kind of a moving state. You see the version is 0.2. I think they're planning for version 1, but it's a bit unclear when that actually is going to be released. And premise 3, which we are using not that extensively, actually less extensively, because we can express a lot of what we had in premise in Fedora 3. We can already express in RIC. But where it makes sense, we're adding like triples from premise and use them. And then, of course, we have like the more Fedora managed data that Fedora creates, which sometimes that duplicates data. I don't think I have an example for that on the slides, but yeah. And then down here, we see the main, like, let's say, resources that we create in Fedora 6. We have record resources that could be any kind of descriptive resource within an archival tree of, like, be it an organization or something lower down, some folder that you have on your file system that, but also has some descriptive meaning. Actors, which are more, part of it is who did actually what with the package before in the process of archiving it. And the other thing is more like, okay, who created the file or the document, who created the image, and so on. Below the record resources, we also have instantiations, which is in premise that this would more be called a representation. Like you can have different formats of your document, be it PDF, maybe the original Word document or whatever it was at the beginning. And then we have binary containers. and binary content. We decided to separate them kind of because we want to store some metadata on the containers, and we can actually more easily, there are situations actually where we want to use, like, store metadata for a binary, but no actual content. And instead of creating like an empty binary in Fedora, we decided we're gonna have a container that describes, yeah, we had a file here that was in format PDF and even had that size, but it was deleted or replaced by a later version of another of this file, migrated to a different format or something like that. And then we have some generic information, like which file formats are in an archive. These always include a link to the Droid signature description, and the ID from Droid, which we are using anyway in the package to identify the file formats. And submission agreements, that's our own implementation, describes a bit, okay, which organization created the package, and could also have some limitations on which files are actually acceptable in such a package. And DocuTeam Box has more a basic UI. I'm quickly gonna go through it. There are a bunch of screenshots from the different parts. What we're seeing here is the cockpit, which is kind of an overview. Data is mostly gathered from the Sparkle index. Shows you, okay, how many types of these different resources that I'm listing here do you have in your repository, which are like the file formats, and yeah, which prefix, that's when we are storing different version, like different organizations within the same repository or sub-organizations. It's just like the first resource, top-level resource within a Fedora, and you can have several of those to separate the content a bit. And here we're seeing there's only one, and it's called test because it's a screenshot from a test instance. Apart from that, we have what we're calling simple search. In the background, it's also running Sparkle queries, but instead of just giving you, well, here you have a text field and you can write Sparkle, but you have to know what you're doing, and you also have to know our data model. This gives you some predefined filters. You can search for a persistent identifier or like the parent object, what belongs to that. Title, which is just a literal in our data model. Creation dates, yeah, as I mentioned, file formats, the resource types that we saw listed here on the right. And yeah, submission agreements, because you want to know, okay, I know this organization uses certain submission agreements, so I want to see what everything that they delivered into the repository. And of course, you can filter by prefixes. The idea behind the results we see down here, currently quite basic. It's just a table that gives you a text representation of the data. In a later version, we're planning that this is somehow also clickable. Maybe you can even view a preview of the document or see like the full metadata when you click into it or drag it out. Hasn't been decided yet. And as I already mentioned, there is a more, let's say, sophisticated search where you can basically do whatever. Where you just type in Sparkle, it has basic syntax highlighting for the Sparkle, and actually it just sends your query that you enter here to Fuseki and returns the result. Down here you can select the different output formats that Fuseki supports, CSV. And as you see down here, I mean, the display of the results is fairly basic. It just gives you a text area, but you can also download it and then do something else somewhere else in Excel or whatever you prefer. And what did I want to tell? What we also have, the update query is actually, you can like predefine such queries, give them a name, so you don't have to remember each time. I know each month I need that data to do some reporting in Excel or send out an email or something. So you can actually just use the same query over and over again and just run it then. Yeah. And let me see. Okay. And most of these functions, the simple search, but also the Sparkle search is also available through an API. So you can even, when you know you have an external application that needs exactly this kind of data in that format, you can store a query here and then just call that one every time you need it, integrate some process in your other application, and which gives us a lot of flexibility to, like, every client has different requirements for how they want to see, what data they want to see at what time, in what format they need for their application or reporting needs. Apart from that, I don't have a slide for the API because I thought, well, showing an API spec is most of the time not that helpful. But basically, apart from searching, you can like get the original of an object, or you can get a like down-rendered version of an object. Of course, only if you have some kind of definition. Okay, how should I render a preview for this file format? So if you want to, I don't know, have a preview of a JSON file, you're probably, I think you're getting an error, getting some kind of status code that tells you, well, we don't have a preview for that format. And you can also get back like the whole package, what should be, or commonly named as a dip, by the persistent identifier. So you just give the persistent identifier of whichever node you want to have, and then you get everything that belongs to that node and everything below it in one package, which is a zip archive containing a METS XML file and all the binary content. Yeah, apart from that, I think that's the most important APIs for now. Yeah. I mean, there are some APIs also that allow you to write data into Fedora or update data, but these are still kind of work in progress. So we're not having any external applications talking to them right now. And yeah, related to the API, we have UI to manage API keys. So you can give different API keys, and you can also assign different Fedora users to the API key. So you can, if you have some ACL in Fedora as well, you can actually really limit the access on the Fedora side, and we're not just doing that on our part of the application. Okay, now I'm coming to the problems with our initial version of the stack, which actually isn't that much related to what we saw in the stack, but more to how do we structure the data? How do we do the calls to Fedora to create that data? First thing we noticed, and also clients noticed when they started doing test migrations, well, and this is like boiled down to the minimal example. You have one package. The package contains one binary file and a mets XML with metadata for it. And I mean, that's in the initial version, what we delivered to clients last year. You get over 200 file system objects in OCFL, around 100 files, and a bit more than 100 folders. That's counting everything, also like the pair tree level of the OCFL and so on. And in OCFL object, it's not that bad, but still for one file, you get 20 different OCFL objects, which also means 20 different Fedora objects. Actually, it might be even a bit more than 20 Fedora objects, because there already is an archival group at some point. Apart from that, we had problems with ingest performance. I don't have numbers ready here, but it was like, okay, we have a reasonably sized package of maybe a few hundred files, and it was taking more than 24 hours to get into Fedora. And the files weren't that big, like small files, but a lot of them. We also, I mean, related to that, had problems with the reliability of getting data into Fedora, because if it takes such a long time, you're just, there can something go wrong in between, your transaction can fail, on the database layer, something can fail. And we also discovered that our indexing solution with Camel Toolbox wasn't that stable. Sometimes it was like, okay, part of it is indexed, but other parts seem like Camel Toolbox never realized there is new content in Fedora. And we had situations where we just basically killed Camel Toolbox, or Camel Toolbox couldn't get any new messages from Fedora. We now know why that is. I'm coming to that later on. But that's what we were seeing. And so at beginning of summer, we realized, okay, we really have to change some stuff to get that working properly. What did we do? I mean, first the results, or this summary you see here, is actually what we got out of deeper analysis. Where are the problems? How are they related? And then we went through hash, did a number of things. We restructured data model, introduced hash URIs, moved the archival group one step higher to get more into one OCFL object. Regarding ingest performance, we started creating Fedora objects in batches. Okay, send 20 requests to Fedora and then wait until they're all done and then proceed. And we do these calls asynchronously, so we just send them and then we collect all the results. Related to the data model restructuring, we just reduced the number of Fedora objects that are created. And we did some fine tuning. Okay, how do we need to configure Tomcat, Fedora 6, Fuseki? What do we need to monitor to get insights? And the indexing problem was actually just related to that the internal broker of Fedora just wasn't fast enough, or Camel Toolbox wasn't fast enough to get rid of the messages that were created, and it just didn't have any space, so it was tied to the memory limits that are there, and bringing this embedded broker to an unusable state. So we introduced a standalone broker, and the internal one now just forwards everything it gets. And that's really fast, just to the external one. And Camel Toolbox does the indexing from there. And we also increased the amount of consumers in Camel Toolbox. So instead of just one by default, we now have, I think, depends a bit on how many resources we have, but something between 5 and 10 normally. Yeah, file-wise, we more or less cut the numbers in half, and OCFL object-wise, we got down, still based on like the single file example from the beginning, from 17 down to 6 objects. Or if you exclude the root, it would be 16 down to 5 objects. I don't know if you can see that, but that's just an example how we're using the hash URIs. Before we had like a separate resource for unit title. Now this is a hash URI and stored within, together with the actual record resource, which also makes sense. We don't need to version that title separately from the object itself. Yeah, that's it. My name is Thomas Bernhart. I'm software and cloud engineer at DocuTeam, and took quite a lot of time, but I think we have a little bit of time for questions or comments.
Yeah, no, that's great. You are right on time. You had 30 minutes from start to finish, so that's perfect. Thank you. Thank you for sharing all that, Thomas. It's been great to see that work progress through and have you at the tech meetings to talk through it. If anybody's interested in the conversation that I say we, like the tech team and Thomas and team had with the OCFL editors about their data model, I can find the YouTube. I'll find the link for the YouTube conversation. We did record it and share it, so I can share it here if people are interested in hearing how that went.
I'll ask maybe a softball question, but maybe not. And I guess I'm just wondering, the ingest performance issues that you were seeing, you kind of alluded that you resolved them through batches and handling them a little more asynchronously. That seems like workarounds rather than well, no, that seems like workarounds. And so as somebody who's involved with Fedora and will be relying on it within our own repository, I guess I'm wondering if you and the DocuTeam team still think there are or have noticed issues with the standalone performance of Fedora on ingest, things that we as the Fedora community should be digging into, addressing. I don't want the solution to be, well, we just changed the way we did everything and then Fedora worked great, right? Like I'd like it if there is a problem that we could identify it, or at least invest some time in trying to identify it.
Okay, so I mean the batches, that was actually our first approach before changing the data model. We just tried, okay, what if we like parallelize the requests a bit more and see what happens. I think part of our problems is that our Fedora instances or this whole stack usually doesn't have that much resources. I mean, the test instance, at least in the cloud, we're talking 2 CPU cores and virtual cores, virtual machine, and I'd say, I'm not sure, 4 or 8 gigabytes of RAM. But I mean, you have Fuseki, you have Tomcat, Fedora, you have Box, which is a Ruby application. You have yeah, there's quite a lot happening on that machine. And I mean, we saw that if we increase the resources, we of course get better performance, but that's more our interest to like keep them as low as possible. And so far, I think we're in a quite good state. But I mean, maybe we wouldn't need the batches if we looked at the data model at first, and this would have already had an acceptable performance. But it would be interesting for us, like, to see, okay, what performance do others maybe get out of Fedora? Maybe we're sending requests wrong. Like, is there a better way? Or I mean, you can always say, well, you're doing it wrong on your side, or Fedora is doing something wrong or not ideal. We just decided, well, the batches might make sense anyway, gives us also some possibility to adjust depending on setup. We're not gonna drop that feature now that we have a better data model.